Today we're going to be talking about factoring polynomials. We're going to start first with our vocab. Standard form of quadratics is y equals ax squared plus bx plus c. In this case, this a, b, and c value, those are all numbers. So if I write an equation that looks like this, y equals x squared plus 7x plus 10, that is a standard form quadratic equation. Now, before I go through and actually factor, we're going to talk about completing the x. This is part of our factoring steps. And so we're going to go through just practicing this step by itself. First, step 1, we're going to multiply a times c, and we're going to place this number on the top of our x. Then we're going to find our b term and place this number on the bottom of the x. And on our calculator, we're going to press the y equals button, and we're going to enter the top number into our equation in the form of y equals that number divided by x. This should look familiar to you because we did this whenever we were trying to find factors back when we were simplifying radicals. We're going to then press second graph, and we're going to find two numbers that are side by side that add to give me the b term. All right, so I gave you all the steps. Now let's go through and we're going to actually put this to action on these two problems right here. So I'm going to start first by multiplying my a times my c. Now, my a, b, and c, if you remember, are numbers. So I'm underlining these values. A is equal to 1 because I don't see the coefficient. B is equal to a negative 13, and C is equal to 30. So when I multiply A times C, I'm doing 1 times 30 to get 30. I'm going to put that in the top of my X. Then I'm going to take that B term, which remember is negative 13, and that goes in the bottom of my X. B in the bottom. Think about it that way. I'm going to go to my y equals screen, and I am going to type in the 30 divided by x to get factors of 30. Then what I'm doing is I'm looking for two numbers side by side that are going to add to give me this negative 13 that's in the bottom. So when I look at this table, you're going to see two factors. Those two factors would be negative 3 and negative 10. Now, if I took those two factors, it should ring true that negative 3 times negative 10 gives me the top number of my x. And then if I add the two, it should give me the bottom number of my x. That's what I'm looking for. So these would be my two factors. In a minute, we're going to take those two factors and we're going to start our factoring process. Let's try a couple more of just determining the x. So I'm going to start first with multiplying my a, which is 1 times c. That's a 1 times negative 60. So that gives me negative 60 in the top of my x. And I want it to add to give me the negative 4 b value. Remember, I'm going to go to my calculator. I'm going to type in y equals negative 60 divided by x. I'm using the top of my x when I look for factors. Now I'm looking for two numbers side by side that are going to add to give me negative 4. When I look at the table, I can see those factors to be negative 10 and positive 6. Remember what we want to happen. We want those two numbers to multiply to give me the top of my x. They do. And we want those two numbers to add to give me the bottom part of my x, which they do. So my two factors would be negative 10 and positive 6. We're going to try two more of these before we actually add in our other factoring steps. So I'm going to multiply a times c, 1 times 24 to get 24. And I want them to add to give me this b value of 10. I'm going to go to my calculator. I'm going to type in y equals 24 divided by x, and I'm going to look for two numbers side by side that would add to give me 10. That would be 4 and 6. Remember, those two numbers should multiply to give me 24 and add to give me 10. They do. So those are the two factors I'm looking for. All right, number 4. Process is the same even if my a value is not 1. So I'm going to do 2 times 1 to get 2 in the top of my x. I want them to add to give me -3 as a b value. I'm going to go to the y equals in my calculator, and I'm going to type in 2 divided by x. I'm going to look for the two numbers side by side that would add to give me -3. That would have to be a -1 and -2, because those two would multiply to give me 2 and add to give me -3. There's my two factors. All right, now that we've practiced that, we're going to look at our steps to factoring. And we have a couple different steps depending upon what type of problem I have. So let's start first with a binomial. Remember, that's a two-term expression. And if I have a binomial that is missing a or c, then I'm going to do what I did in the previous lesson, which means I'm going to factor out the GCF only. If my binomial is missing b, and my c value is a plus, a positive, I'm still going to factor out the GCF. However, if that c value is a negative, I'm going to have some extra steps that I haven't had yet. In this case, I'm actually going to still factor out the GCF to start, but then I'm going to add a 0 in place of the b term. So I'm going to have a 0 in whatever variable I'm talking about. And then I'm going to factor it as if it was a trinomial. So my steps are going to be always to start with factoring out the GCF. Then I would create an x, and from there I'm going to split my middle term into the two factors that I found in my x. And I'm going to factor by what we call grouping. So I'm going to show you some examples of this. Let's look at example number 1. Remember, step 1 is always, no matter what, going to be factor out GCF first. So if I'm factoring out the GCF here, you'll notice in my first two terms, they have nothing in common. If they have nothing in common, then I know I can skip that step. So I'm going to go on to the next thing, and I'm going to create my x. So I'm going to multiply a times c, just like we've been doing. That gives me 30, adds to give me that middle term of -13. Remember, I'm going to go to my calculator, type in y equals 30 divided by x. I'm looking for my two factors that would add to give me -13. We know those two factors to be -3 and -10. Now here's where the new part comes in. I'm going to take these two factors and I'm going to do what we call split the b term. The b term we know is the middle term. So instead of saying -13x, I'm now going to say -3x and -10x. Whatever variable is on here is what I will add to the back of these two factors. So I add an x to both of those. I'm going to drop down this first term of x squared, and I'm going to drop down this last term of plus 30. From here, I'm going to do what's called group. So I'm going to kind of put a line down the center of this. I'm going to focus on just this first half of my polynomial. So I'm looking at just these first two terms, and I'm going to factor out the GCF of just those two. So looking at those, they have an x in common. So remember, I'm going to divide both by x. They don't have a number in common. This x I divide by, remember, goes out in front of parentheses, and what I have left after I divide should go inside parentheses. Since it's a binomial, I should have a binomial left inside the parentheses. Well, x squared divided by x, if I take an x out of that, I'm left with a single x left. Then -3x divided by x. Remember, x divided by x is 1, so those go away. So I'm left with negative 3. I could do a quick distribute to double check that it is equivalent to what I started with, which x times x is x squared, and x times negative 3 is negative 3x. That's a quick, easy check step. All right, now I'm going to focus on the back two terms, and I'm going to do the exact same thing. I'm going to factor out the GCF of these two. Remember, whatever the sign is of that first term should be the sign of the GCF. So that's negative. I'm going to drop that down. Now they both have a 10 in common, so I'm going to divide both terms by negative 10. They do not share a variable, so I won't have that as part of my GCF. So I'm writing my negative 10 in front of a set of parentheses. Negative 10x divided by negative 10, well, those go away and create just a 1x. And 30 divided by negative 10 is negative 3. Again, I could do a quick distribute to double check. Negative 10 times x is negative 10x. And negative 10 times negative 3 gives me a positive 30. So we know we've done it correctly. Now when I get here, you should notice that these two parentheses are the same. If you have done it correctly, that will happen every time. So I'm going to take these matching ones and I'm going to write it one time. It's kind of like when we simplified radicals, we circled pairs and we only pulled one out. Same kind of concept here. I see a pair, I'm going to pull one out. Now I'm going to have a second binomial, and that is made up of what was left over that I haven't used yet. And that is this x and this negative 10. So I'm going to drop that x down and I'm going to drop that negative 10 down to create a second set of parentheses. This is my final answer. And what this is saying is that this is equivalent to what I started with. So I could do a quick proof or check step, and I could distribute or double distribute or FOIL or box these two binomials together in order to double check that it's equivalent. So I'm going to distribute that x. So x times x gives me x squared. X times negative 10 gives me negative 10x. Now I'm going to distribute that negative 3. Negative 3 times x is negative 3x. And negative 3 times negative 10 is positive 30. Remember, I can combine these like terms, and that would get me x squared minus 13x plus 30. You can see how this is equivalent to what I started with, so we know we've done it correctly. These problems have a lot happening in them, so it's really easy to make a mistake. So try not to get overwhelmed with everything that we're doing. Just take it piece by piece. Okay, so I'm going to go back to the beginning. I'm going to look for a GCF. You can see right here that these two don't have anything in common, so I know that there's definitely not going to be a GCF. I'm going to go to my x step. So 1 times negative 60, I'm going to make my x, place negative 60 in the top, adds to give me that negative 4 b value. Again, I go to my y equals screen, I type in my negative 60 divided by x. I'm going to find that those two factors are positive 6 and negative 10. Now remember, whatever variable is on this b term is what variable I add to those two factors. I'm going to split this middle term to be a positive 6a and negative 10a. Because if I combine those, I get back to that negative 4a. I'm going to drop down my a squared. I'm going to drop down my negative 60. Here's where I group. I'm going to focus on just these first two terms. I'm going to find the GCF of those two. They have an a in common, so I'm going to pull that out. Remember, whatever I divide by has to go in front of parentheses. If I pull an a out of a squared, I'm left with a. And if I pull an a out of 6a, those would cancel out, and I'm left with positive 6. Look at the second half of my polynomial. I'm going to drop down this sign every time. They share a negative 10 in common. So I'm going to put that out here in front of parentheses. Negative 10 divided by negative 10 leaves me just a, and negative 60 divided by negative 10 leaves me positive 6. Remember, when I get to this step, I should notice that the two parentheses are the same. If they're not the same, that's a dead giveaway something is wrong. I'm going to write that one time. So those two come together to make that one binomial. My second binomial, remember, is made up of what was left that I didn't use, which is the a and negative 10. So I'm going to bring this a down and this negative 10 down. That makes my two binomials. Again, I could do a proof or check step to check my answer by double distributing, FOIL, or box to make sure I got back to the starting problem. A times a is a squared. A times negative 10 gives me negative 10a. 6 times a gives me positive 6a. And 6 times negative 10 gives me negative 60. Combine those like terms, and I get a squared minus 4a minus 60. That is what I started with. I know I've done it correctly. All right, now that I've kind of shown you the proof step, I'm going to skip that step just to save time on the video, and I'm just going to focus on the factoring side. All right, step one, I'm going to look at my first and last term. Do they have anything in common? No. If they did, I would have to make sure that they had something in common with the middle term as well. Since these don't, I can skip that step, and I'm going to multiply a times c. 1 times 24 gives me 24. We want to add to get me 10. I'm going to go to y equals, and I'm going to type in 24 divided by x to find two factors that add to give me 10. That would be 6 and 4. Whatever variable is right here is what I add onto both of those, and I'm going to use these two factors to split my b term. So it's going to be a positive 6x and a positive 4x. Drop down x squared and drop down positive 24. I'm going to split this. I'm going to focus on just the first two terms, and I'm going to look for a GCF. They both share an x in common, so when I divide by x, that's what's going to go out in front of my parentheses. X squared divided by x, if I pull an x out, I'm left with just an x. And 6x divided by x, those x's would cancel out, and I'm left with a positive 6. Now I'm going to focus on the back two terms. I remember, whatever that first sign is tells me the GCF. I have to put that positive sign there. That's going to matter later when I write my binomial. What goes into both is a 4. So that number goes out in front of my parentheses. 4x divided by 4, the 4's would cancel out, and I'd be left with x. 24 divided by 4 leaves me positive 6. I can double check these match, so I know I've done it correctly. So my first binomial is x plus 6. My second binomial is going to be x plus 4. Again, I could do my check step to make sure it comes back to be my starting problem. Again, I'm going to skip that for the time being just to save time in the video. All right, number 4. I'm going to start first by looking for a GCF. If you notice, 2m squared and 20 have a 2 in common. So I'm going to double check. Does 2 also go into 14m? And the answer to that is yes. So that means I'm actually going to divide all three terms by 2. They do not have a variable in common, so I won't pull a variable out. I'm going to write that in front of a set of parentheses. And I'm going to simplify. 2m squared divided by 2 would leave me just m squared. 14m divided by 2 would leave me 7m. And 20 divided by 2 would leave me 10. Once I get here, I'm actually going to then factor what's left over inside of these parentheses using all the things I've been doing by creating my x. I'm going to basically ignore this 2. I'm actually going to carry it down because it's going to become part of my answer. And this is what a lot of people forget about, is they forget to include that as part of their answer. So I'm going to drop that down so I don't forget. And then I'm going to focus on just the parentheses. I'm going to multiply A times C, make my X. 1 times 10 is 10, adds to give me that B term of 7. Go to y equals, type in 10 divided by x. That's going to be the outcome of 2 and 5. Remember, whatever variable is right here is what I add on to those 2 factors. And I'm going to split that b term to be positive 2m and positive 5m. Bring down my m squared, bring down my positive 10. I'm going to split this. I'm going to look for a GCF of just the first 2 terms. They both have an m in common, so I'm going to divide them both by m. That would leave me an m plus 2. Then I'm going to drop down my positive sign. These have a 5 in common. So I'm going to place that 5 out in front of my parentheses. Divide by 5, that would leave me m plus 2. You can see that these 2 parentheses match. So I'm going to write that as my first parentheses. And I'm going to take those leftovers that I haven't used of m plus 5, and that's going to make my other binomial. Now, if you remember, that has to get me back to my starting answer. Now, I told you the most common mistake people make is that they forget the 2 out in front of their answer. So, really important check step on this part. So how I would do it is I'm going to take just the first 2 and I'm going to distribute those. So 2 times m is 2m, and 2 times 2 gives me 4. I'm going to then multiply that by the second parentheses by double distributing. 2m times m gives me 2m squared. 2m times 5 gives me 10m. 4 times m gives me 4m. And 4 times 5 gives me 20. When I combine those like terms, I get back to 2m squared plus 14m plus 20. If I would have only done the 2 parentheses and I would have forgotten the 2 out front, it wouldn't have matched. So that would have been a giveaway that I forgot to include my very first GCF as part of my answer. All right, let's look at a few more examples. Number 5, I'm going to start first by looking to see if there's a GCF. So I'm going to look at the first term and the last term. They don't have anything in common, so I know that there's not going to be a GCF to factor out at the beginning. I'm then going to do my a times c, and I'm going to make my x. 2 times 1 gives me 2, and I want what adds to give me -3. Remember, I'm going to plug that in my calculator. Y equals 2 divided by x, and I'm going to look for the 2 factors. The 2 factors in this case would be a -1 and a -2. I'm going to take whatever variable is on that b term, and I'm going to add that to those 2 factors, and those are going to be the factors I use when I split my b term. So I'm going to split this b term to be a -1x and a -2x. I'm going to drop down that a of 2x squared and the c of +1. I'm going to split into 2 pieces. I'm going to look at the GCF of these first 2 terms. I can see that they both share an x in common, so I'm going to divide them both by x. Remember, that's going to go out in front of my parentheses. I'm going to pull an x out of each term. So if I pull an x out of 2x squared, I would be left with a 2x. And if I pull an x out of an x, those would cancel out, but they would actually become a -1. I would need that there because if I don't have that there, then when I went to distribute to check to make sure it was equivalent, it wouldn't work. I would just have a 2x squared and I would have no -x. So make sure you have that -1 there. Then I'm going to look at the back binomial. I'm going to drop down that negative sign, and they don't have anything visible in common, but remember what goes into everything is a 1. So I'm going to divide by -1 to both terms. So remember, a -2x divided by a -1 would leave me a positive 2x, and 1 divided by -1 would leave me -1. Remember, we want to double check to make sure that these two binomials match. They do. So that's going to become my first binomial. And then remember, my leftovers, I'm going to combine to make my second binomial, x minus 1. Again, remember that you can FOIL those or box method to double check my answer. I'm going to skip that step just to save some time on the video. All right, on number 6, I'm going to look first at that first term and last term. They don't have anything in common, so I know that there's no GCF to pull out. I'm going to go to my next step where I'm going to multiply A times C. 5 times -63 gives me -315, and I want it to add to give me 38. I'm going to go to my calculator, type in y equals -315 divided by x, and I'm going to look for two numbers side by side that add to give me 38. That is going to be -7 and +45. Remember, whatever variable is on that middle term, I'm going to add to those two factors, and that is what I'm going to break my b term to. So it's going to become a -7r and a +45r. I'm going to drop down that a term of 5r squared and drop down the c term of -63. I'm going to split these into 2, and I'm going to look at the first set binomial and see what do these have in common. They both have an r in common, but nothing else, so I'm going to divide both by r. That's going to come out in front of my parentheses. If I pull an r out of 5r squared, that's going to leave me 5r. If I pull an r out of -7r, that's going to leave me -7. Now I'm going to look at the back binomial. I'm going to drop this sign down, and I notice that a 9 goes into both. So that's going to be my GCF. They do not share an r in common, so that's my only GCF. I'm going to divide 45r by 9. That leaves me 5r. And -63 by 9 gives me -7. We can see that these two binomials match, so I know I've done it correctly. That's going to be my first binomial. My second binomial is going to be my leftovers of r plus 9. Again, I can double distribute or FOIL or box to double check my answer. All right, number 7. I'm going to start first with looking at that first term and the last term. Notice that these have a 3 in common. However, a 3 will not go into 5, so there is not a GCF between all 3 terms. So I'm going to skip that step. I'm going to multiply 3 times -12. That gives me -36. I want it to add to give me 5. I'm going to plug this into my calculator of y equals -36 divided by x. I'm going to find that my two factors have to be -4 and +9. I have a p for my b term, so that gets added on both of those factors. I'm going to split my b term to those two factors of -4p plus 9p. I'm going to drop down my a term of 3p squared and my c term of -12. I split to two pieces. Looking at my first binomial, I'm going to look for a GCF. They both share a p in common, so I'm going to put that GCF out in front of parentheses. If I pull a p out of 3p squared, I'm left 3p. And if I pull a p out of -4p, I'm left -4. Now I look at the back binomial. I can see that the two of these have a 3 in common. Remember, I'm going to drop down that sign and put that GCF out front. 9p divided by 3 leaves me 3p, and -12 divided by 3 leaves me -4. I can see that these two match, so that is my first binomial. And I'm going to add my leftovers to make up my second binomial. So my second binomial would be p plus 3. Number 8, I'm looking at the first term and the last term. They have nothing in common, therefore there's no GCF to factor out. So then I'm going to do a times c. So I want factors of 9 that add to give me 6. I go to my y equals screen and I type in y equals 9 divided by x, and I look for my two factors that would add to 6. That would be 3 and 3. Remember, I tack on the x to both, and I'm going to split my b term into positive 3x and positive 3x. Drop down my a term of 9x squared, drop down my c term of positive 1. Split this into 2. Look at my first binomial. I can see that these have a GCF of 3, but they also have an x in common. So I'm going to pull a GCF of 3x out, put that in front of my parentheses. 9x squared divided by 3x. Well, 9 divided by 3 is 3, and if I pull an x out of x squared, I'm left x. And then 3x divided by 3x, anything divided by itself is 1. All right, then I'm going to go to my back binomial. I'm going to look for what's in common here. They don't have anything in common, but remember what goes into everything is 1. I'm going to drop that addition sign down and put my GCF of 1 out front. 3x divided by 1 is 3x, and 1 divided by 1 is 1. I see that these two binomials match, so that's my first parentheses. And I take my leftovers of 3x and 1 and make my second binomial. Now, look what you see. You see the same binomial twice. So technically, this can be written as 3x plus 1 with a squared outside. And we do expect to see you write it that way. All right, just two more on this page. Now, notice on these problems, they look a little bit different because now I'm dealing with a binomial. So I have to pay attention to the fact of what scenario is it going to match. This is missing a b term. And remember, anytime I'm missing a b term, I then have to evaluate, is the c positive or is the c negative? Since the c is a negative 81, I'm going to first look to see if there's a GCF between the two. There is not. So then I'm going to move to step 2, which means I have to add a 0 in the middle for the b term. Now, since the a term is measured in x's, the b term will also be measured in x's, and then I add my negative 81. Now it looks like a trinomial, just like we've been doing from the beginning, so now I'm ready to follow my trinomial steps. I'm going to add a 1 here and multiply 1 times negative 81. So I want what multiplies to give me negative 81 and adds to give me a 0. Anytime I have a 0 as my b term, that is an automatic giveaway that my two factors are going to end up the same number but opposite signs. So again, I can still follow the same steps of do negative 81 divided by x and look for my two factors. In this case, my factors are going to be positive 9 and negative 9. Since my b term is x's, we're going to add an x on both of those factors. I'm going to use those two factors to split that b term to a positive 9x and a negative 9x. Drop that a term of x squared down and that c term of negative 81 down. Split into two pieces. I'm going to look at the first binomial. I see that these two have an x in common, so I'm going to divide by x, put that out in front of my parentheses. If I pull an x out of x squared, I'm left x. If I pull an x out of 9x, I'm left a positive 9. Now I'm going to look at the back two, this back binomial, and I see that they have a negative 9 in common, because remember, whatever this sign is has to be the sign of that GCF. So I'm going to put a negative 9 out front of my parentheses. Negative 9x divided by negative 9 leaves me x, And negative 81 divided by negative 9 leaves me positive 9. Remember, these two parentheses should match if we've done it correctly. They do, so that is my first answer. And my second binomial is going to be the leftover pieces that are x minus 9. Anytime I have a binomial where the middle term is missing, the b value is 0, and the c value is negative, it's always going to end up the same binomial but opposite signs. All right, number 10. First thing I'm going to do is I'm going to look to see if there's a GCF. Notice that there is a GCF between these two terms. They both have a 5 in common. And remember, I have to take the sign of that first term. So I'm going to actually divide both terms by a negative 5. I'm going to put that out in front of parentheses. Negative 5a squared divided by negative 5 leaves me a squared, and 5 divided by negative 5 leaves me negative 1. From here, I am not done. I then have to analyze to see if I can factor what's left over inside the parentheses. So this is a binomial, so I analyze what type of binomial is it. It's one that's missing the b value, and c is negative. So remember, this is a case where I can add a 0 in the middle for my b term. First thing I'm going to do is drop that negative 5 down into my answer so I don't forget about it. I'm then going to add a 0, and don't forget the variable that I'm using for my a term helps me figure out what my variable for my b term will be. And I have negative 1. Now I'm ready to do a times c and make my x. So 1 times negative 1 gives me negative 1 and adds to give me a 0. I'm going to go to my y equals, type in negative 1 divided by x. That gives me my two factors of positive 1 and negative 1. Since my b term has an a on it, I'm going to tack that on both factors, and that is what I'm going to split my b term to. So I have a positive a and a negative a. Drop down my a squared, drop down my negative 1. Split this into two binomials. Looking at my first binomial, I see that they have an a in common. So I'm going to divide both by a. Remember, that comes out in front of my parentheses. If I pull an a out of a squared, I'm left a. And an a divided by a gives me 1. Look at my back binomial. I'm going to see that they don't have anything obviously in common, so that means it must be a 1. And since that first term is negative, I'm going to do it by a negative 1. Put that out in front of my parentheses. Negative a divided by negative 1 leaves me a positive a, and negative 1 divided by negative 1 leaves me a positive 1. Now I see that these two parentheses match, so that gives me that first binomial of a plus 1, and then I take my leftovers of a minus 1 to make up my second binomial. Don't forget the entire thing, including that negative 5, is your answer. All right, number 11, we're going to look first for a GCF. Remember, we can look at the first term and the last term. Notice on this problem, there's a difference because both the a and the c both have a variable and they're different. We're going to approach it the same type of way. It's just when I split my two b terms, I'm going to have two variables on that b. So when I look at my a and my c, they're going to have nothing in common. So that means all three cannot have a GCF. So then I'm going to go to my a times c. 16 times 25 will give me 400. And we want it to add to give me 40. So remember, I can go into my calculator. I'm going to type in y equals 400 divided by x. I'm going to look for my factors. My two factors would end up being 20 and 20. Remember, this has a PQ on the b term, so that's what I'm going to add to both of those factors. I'm going to use those two factors to split that b term. So that's going to become a positive 20 PQ and positive 20 PQ. Drop down my first term of 16p squared. and my last term of 25q squared. From here, I'm going to group the first two terms together, and remember, I'm going to group the last two terms together. Looking at just the first two terms, I'm going to pull the GCF out. If I look at just 16 and 20, they both have a 4 in common. And then if you also look at your variables, they both have a p. So I'm going to pull that out into the front of parentheses, and I'm going to divide. 16 divided by 4 gives me 4, and if I take a p out of p squared, I'm left p. 20 divided by 4 gives me 5. If I take a p out, those would go away, and I'm left with the q. All right, look at the back two terms. Remember, this sign has to drop down always. 20 and 25 have a 5 in common. And if I look at the variables, they also share a q in common. I'm going to write that down out in front of my parentheses, and I'm going to divide. 20 divided by 5 gives me 4. If I take a q out, I'm left just p. 25 divided by 5 gives me 5. If I pull a q out of q squared, I'm left q. Now when I get here, remember, you can see these two parentheses match, so we know we've done it correctly. That's going to be my first binomial of 4p plus 5q. Then I'm going to take my leftovers of 4p plus 5q to make up my second binomial. Now when I write this out, what you notice is that the two binomials are the same, so remember I can condense that down to 4p plus 5q with a squared outside. All right, let's take a look at number 12. We're going to start first with looking to see if there's a GCF. There is nothing in common between the 4 and the negative 121. So then I'm going to go to adding my b term, because notice this is only a binomial and I'm missing that middle term because I have two terms that are squared, so that must be the a and the c term. You're never going to have a squared term in that middle, that b value. So I'm going to rewrite this problem as 4a squared plus 0, and I'm going to take both of these variables, a, b, and then I'm going to have minus 121b squared. Now I'm ready to do a times c and make my x. So 4 times negative 121 gives me negative 484, and we want it to add to give me that b value of 0. So when I look at those two, I know that my two factors have to be the same. I'm going to go into my calculator and type in my negative 484 divided by x. Since they add to give me 0, they have to be the same number, different signs. That's going to give me a positive 22 and a negative 22. I'm going to take the variable that's on the b term, which is ab, and add that to both of my factors. I'm going to split that b term to be positive 22ab and negative 22ab. Bring down my first term, 4a squared, bring down my last term, negative 121b squared. Split my expression into two, so I group the first two and the last two. Looking at the first two, I can see that 4 and 22 have a 2 in common, and they also both share an a. That's going to come out in front of my parentheses, and I'm going to divide. 4 divided by 2 gives me 2, and if I take an a out, I would be left a. 22 divided by 2 gives me 11, and if I take an a out, I'm left with a b. Drop this sign down. I notice that 22 and 121 have an 11 in common, and they both share a b. So negative 11b is my GCF. Now I'm going to divide. Negative 22 divided by negative 11 is positive 2. If I pull a b out, I'm left a. Negative 121 divided by negative 11 leaves me positive 11. And if I pull a b out, I'm left with 1b. When I get here, Remember, I can see that these two parentheses match. We know we've done it correctly. That's going to be my first binomial, 2a plus 11b. And then I'm going to take my leftovers, 2a minus 11b, and that's going to be my second binomial. All right, number 13, I can see it's a binomial, and it's actually missing my c term. I'm going to always start first, remember, either way with my GCF. So if you can't tell that it's missing c, that's okay. I'm going to start first with GCF always. So I can see that both of these have a 3 in common, and they both have an x squared in common. So that comes out in front of parentheses, and then I'm going to divide. 6 divided by 3 leaves me 3, and x to the 4th divided by x squared leaves me x squared. For my second term, I have 3 divided by 3, which gives me 1. I don't need a coefficient of 1. And x squared divided by x squared gives me 1. Now I do have to have a term there, and since both of them cancel out to a 1, I'm just going to include a 1. If I don't put that there, then when I check, I would only have a monomial when I multiply. And you can clearly see my initial expression is a binomial. So you can easily fix mistakes on this one by doing a quick check. If I distribute, that gives me my 6x to the 4th, and if I distribute that, that would give me my 3x squared. So we know we've done it correctly. If I didn't have the 1 there, it would just give me the 6x to the 4th. Number 14, always going to start first with my GCF. So they don't have a number in common, but they do both share an x and a y. So I'm going to divide both by xy. That's going to come out in front of my parentheses. If I pull an xy out of 9x squared y, I'm left with 9x. If I pull an xy out of xy, that would just leave me a minus 1. Remember, I have to have the minus 1 there. It can't disappear, or it wouldn't be equivalent. All right, number 15. This is actually the same type of problem. It just looks a little bit different. So what I'm actually going to do is I'm going to take the top half of this, and I am going to factor. And the bottom, I am going to temporarily ignore. So I'm going to focus on just that x squared plus 6x plus 9. Looking at this, my first and last term have nothing in common, so there is no GCF to pull out. So I'm ready to do a times c. I'm going to make my x. 1 times 9 is 9. We want to add to get 6. Type in my calculator, y equals 9 divided by x. That's going to give me the 2 factors of 3. Since I have an x on my b term, that's what I add to those 2 factors, and that's what I'm going to split those to be. So I have a positive 3x, a positive 3x, drop down that a term of x squared, and that c term of 9. I'm going to split this into 2. Looking at the first binomial, I see that they have an x in common. That's my GCF. Pull that out in front of parentheses. Pull an x out of x squared, I'm left x. Pull an x out of 3x, and I'm left with just 3. Look at the back binomial. Notice that these have a 3 in common, and since that first term is positive, that's what I'm going to pull as my GCF. Positive 3. 3x divided by 3 leaves me just x, and 9 divided by 3 leaves me 3. Notice that these 2 parentheses match, so therefore my first binomial is x plus 3. Take the leftovers of x plus 3 to make that second binomial. Now here is where it's a little bit different. This bottom denominator is 1 parentheses. My answer is the other parentheses. All right, let's try one more like that. I'm going to start first with, remember, I'm just going to factor the numerator. Looking at the numerator, this term and this term have a 2 in common, but a 2 will not go into that b term, so there is no GCF. I'm ready to go ahead and do my a times c. 2 times 2 gives me 4, and we want adds to give me 5. Type in y equals 4 divided by x to find my two factors as 1 and 4. Add an x onto both since that's what's on my b term. And I'm going to split my b term to those two factors, positive x and positive 4x. Drop down my a term of 2x squared and my c term of 2. Split into 2. Looking at the first binomial, I see that they have an x in common. Pull that out in front of my parentheses. 2x squared divided by x. If I pull an x out, I'm left 2x. X divided by x, remember anything divided by itself is 1. Look at the back binomial. I see that they have a 2 in common, and since that first term is positive, that is what I'm going to divide by. So my GCF is positive 2. 4x divided by 2 leaves me 2x, and 2 divided by 2 leaves me 1. Notice that these two parentheses match, so that is my first binomial. And take my leftovers of x plus 2 to make my second binomial. Now remember here where it's different, that denominator is one of your parentheses, your answer is the other parentheses. All right, we are down to just 2 examples and their application problems. So let's look at number 1. It says a packing box has a volume of 4x squared minus 56x plus 192. It wants to know what are the possible dimensions of the box. All this is wanting me to do is factor that expression. So the first thing I'm going to do is look at that first term and that last term to see if there's a GCF. There is a GCF. 4 actually goes into both. So I need to double check, does 4 go into negative 56? The answer to that is yes. So I'm going to divide all 3 of those by 4 to start. Remember that 4 is going to come out in front of parentheses. 4x squared divided by 4 will leave me just x squared. Negative 56 divided by 4 leaves me negative 14x. And 192 divided by 4 leaves me 48. Now that I'm here, I have a trinomial in the parentheses, so I'm ready to do my x. I'm going to multiply 1 times 48 to get 48, and I'm looking for a number that adds to be negative 14. So I'm going to type in my calculator, y equals 48 divided by x. I'm going to find that my two factors would be negative 8 and negative 6. Since x is on my b term, that's what I'm going to add to both of those. I'm going to split my b term to those two factors of negative 8x and negative 6x. I'm going to drop down that x squared and drop down that 48. I'm going to split this into 2. Now don't forget, you need to take this 4, that was your initial GCF, and I'm going to move this over to be part of my final answer so I don't forget about it. I'm going to look at that first binomial. I see that they have an x in common, so I'm going to divide both by x, pull the x out in front of parentheses. X squared divided by x leaves me x, and negative 8x divided by x leaves me negative 8. Look at the back binomial. I see that a 6 goes into both, and since that first term is negative, I'm going to divide by a negative 6. Open my parentheses, negative 6x divided by negative 6 leaves me x, and 48 divided by negative 6 leaves me negative 8. I notice that these two binomials are the same, so remember that's my first binomial. And then I take my leftovers of x minus 6, and that makes my second binomial. Now the question said, what are the possible dimensions of the box? So basically what we say is that 4 is like my length, x minus 8 is like my width, and x minus 6 is like my height. All right, we have one more. You are given the following information about a tabletop you are building. The area of the tabletop is x squared plus 10x plus 16, and the length of the tabletop is x plus 2. What is the dimension of the width of the tabletop? So this is like the last two examples before we got to the word problem. I'm actually going to take this problem and I'm going to write it out as x squared plus 10x plus 16. And I'm basically dividing it by my x plus 2. And the reason for this, if you remember, my formula is length times width, right? And if I know that my area is x squared plus 10x plus 16, and I know my length is x plus 2, and I don't know my width, remember I can divide by that length to find my width. So you see where we get that problem from. All right, so now what I'm going to do, remember, is factor that numerator. There is nothing in common with x squared and 16. So I'm ready to go ahead and do my a times c. That will give me 16, and I want what adds to give me 10. So I'm going to type that in my calculator, y equals 16 divided by x, and I find that my two factors are 2 and 8. I'm going to use that variable of x on both of them, and I'm going to split my b term to those two factors. So I have positive 2x, positive 8x, drop down that a term of x squared and that c term of 16. Split into 2. Looking at the first binomial, they both share an x in common. I'm going to pull the x out in front of my parentheses. Pull an x out of x squared, I'm left x, and a 2x divided by x, I'm left 2. Look at the back binomial, I see that they have an 8 in common. And since that first term is positive, I'm going to divide by a positive 8. Put that out in front of my parentheses. 8x divided by 8 leaves me x, and 16 divided by 8 leaves me 2. We see that these two binomials match, so that is my first binomial. And then I use my two leftovers of x plus 8 to be my other binomial. Now remember, x plus 2, it already told me that that was my length. So that means when it asks what is my width, that would be my other leftover of x plus 8.